might want to use the default threshold settings for the outlier identification, or you may want to use a little bit more, something a little bit more conservative, or something a little bit more liberal if you are scanning kids. So there are many things that are still that not any individual pipeline is going to capture like the optimal way to analyze your data for every case. I mean, so it's a little bit of a trade-off. How many do you want me to throw away pretty much all possible options in there as different pipelines? Do you want to just have a few pipelines and then just have the flexibility to change them? What do you think is going to work best in terms of practical use?
One thing that might be helpful as a separate thing to have in there is something that is specific for sparse sample designs versus continuous sample designs, because I think you wouldn't normally do a slice timing correction if you're just acquiring one sparse.
Right, exactly.
So, you know, something that maybe specified like that it was for a sparse pipeline or something, that so that wasn't included, that might help.
That makes sense. That's a good idea.
Investigators don't typically do continuous though for production experiments, right? Because
sometimes do. Sometimes do. So we do have some continuous data. Yeah, the representational suppression stuff.
Oh, okay.
But yeah, so I think the two volume-based that we talked about, those are the good default ones. And something, you know, if you have, I guess, like a pipeline, like solid saying that has a continuous and a sparse, or some way. I guess.
Right. I mean, currently, I don't think any of our pipelines actually include the slice timing correction, right? I think so, but I'm not totally sure. So in that case, either continuous or acquisition would use pretty much the same identical preprocessing steps. They will vary. They would be different when you get to the first level analysis, like default settings, but not in terms of preprocessing, right?
Even if it's just, if we have the config files, an example config file that's in the manual for pipeline that says these configurations typically for sparse sample data, because that's mostly going to be in that config file yesterday.
Oh yeah. So the the first level design config file, it would be great to have a separate one for a sparse design versus continuous design.
Yep, that's a good point. Yes, definitely.
And annotated.
Right, and okay, yeah, we'll continue talking about the first level later, but just okay. So and this difference that you were showing us here, Elaine, on this data set, are they kind of like other subjects are similar in their properties? Basically, you look at them, I'm sure, like in more detail than we could. But do you see kind of like the same thing, basically, that the indirect pipeline in general shows a better correlation?
Right, and again, like the biggest difference is between field maps, no field maps, and then the flat load improvement with the indirect.
Right, and did that happen also? I seem to recall that your first two subjects had some this different like field map information that we weren't totally sure whether that was working correctly or not. So what happened with those two subjects? Are they still showing better normalization through? Sorry, go ahead.
I might just bring them up actually, just I think that would still be useful one to look at as a group.
so the first two subjects do not have field maps.
They do have field maps, but their field maps are different. So we don't have
okay.
an image with them. So in this case, we just used the first functional. So basically, asks the different maps. Do you want to show the structural?
I think it's, when you're looking at these as just general practice, it's good to load it and then just convince yourself those yellow lines are in a good place. Oh, I think it's because you have to get rid of the, wait, no, there's a way to do it so you only see the structural. If you take the, I think if you
Oh no, you still need just make the, if you take the overlay all the way to the left, I think you only see the structural, right? Yeah. And then just find a threshold that captures that like a gray to white boundary reasonably well, and that should work. Yeah, a little bit less probably.
This is the MNI space for that field.
without the field maps. And but then the other thing is that it's also kind of handy. Looking at this is fine. We'll see the information, but it's also good to look at the axials and the sachets.
Right.
Because it's giving you a way you can see where without the field maps there's a problem. You know, sure.
Right.
Yeah, so like right there, just gonna shift it back. Oh, well, the functional switch. Now I'm doing a great job here, and I'm assuming that it's not going to do a great job here. So. Okay, so
That's the MNI one.
M and I know.
It is direct with field maps. This
It's not perfect, but
All right. One's
Oh.
biased. Yes.
would make some gorgeous.
So this is, I mean, what, just looking at the difference between the last one and this one, and then what we saw yesterday, we are having to, I am changing my opinion on what is a good co-registration. Because most of the ones we looked at before, they weren't using the field maps, and they definitely look better with the field maps.
Yeah, we weren't outrageously concerned before we knew field maps.
Yeah, I think if we see something like what we saw before, those didn't look good. We noticed that they didn't look good. I think we were maybe you see that on some subjects. I think looking at the other one here, the direct one with the field maps, that I would have considered like completely tolerable
Right.
error, but this is definitely better.
It's,
Direct field maps instead of this indirect. I mean, that there's error, but it didn't seem like that. But this
this comparison between the three different pipelines, they're giving us a nice, like, examples of what is okay, and what, like where that level is. Because that anchor, I think, is sort of kind of tricky, but they might be good images to put out or to a PowerPoint.
Yeah. So if you get someone to go back through the video, you pull out some slices. Unfortunately, there's no on there. But,
Now, just practically speaking, how will you address this with reviewers that like some of the subjects have different field maps than others?
Well, it's not, I don't think it's a big,
It's not.
because like we're just for two subjects where we're putting in a different image that is serving the same purpose as what's missing. Whereas like in the A student, for example, they're using two completely different field maps, like flips versus the.
yeah, I mean, I think you can say something like, so for this, it's everybody's in the same.
Right.
So you could just, it's legit to say that we correct it for unworked.
And the improvements you're getting by using the different, they're not, they're only slightly different. It's way better than not using them.
Mm-hmm.
I don't know that you need. Well, we'll see how this goes.
Like, I mean, in general, in practical terms, if we had found like more noticeable differences in how the field map and warping worked in these two cases than the other, then we would be concerned about that, and we would want to either remove those subjects or make sure that we have an additional covariate to make sure that whatever results we are looking in our data are not biased by this potential difference between these subjects and the rest. But it's impractical in this case, since we are not observing that, we are not particularly concerned about potential difference because we don't see any of those, at least visually. We will probably just double check. I mean, at the end, when we get some second level analysis, we'll just remember to make sure that these two subjects are an additional covariate to make sure that the result is not biased by these two, or that we are missing something. But other than that, I think we are fine. We can just use the subjects as they are, basically, or as. But I mean, the situation would have been totally different if we had seen some obvious differences in the way that unwarping worked for those two subjects. If we saw the data to be worse quality in the level of co-registration, because that could potentially produce like biases in our second level analysis later on.
What should we do for the rhythm study? We're collecting field maps for all the new subjects. And now we don't have any for the old one. I know. I mean,
one. Well. Yeah, I don't know. I guess we don't use them, but I'm still waiting for you one day for you to send me an email. Hey, wait, I found these field maps because of course we got them because we were supposed to, and we had the protocol that we made. And what's interesting is that SRAG, which is run at the same time in parallel by the same two people, has them.
And they were undiscovered until.
They were undiscovered.
oh.
Yeah.
And this data has been processed multiple times with that. But the folder, you saw the other day, or you got a glimpse of our 27-page document explaining our structure of the SRAG data.
Yeah.
So the maps were in there, but they were buried.
What you may want to do is use. Well, no. So you didn't unpack these things, right?
No, I just went through at various stages. I've just gone through every directory and subdirectory just looking for information.
I think in this case, Matthias tried to unpack it so that it just unpacked everything.
Yeah.
And didn't see them.
Exactly. But yeah.
But yeah, I mean, it doesn't take long to collect them, so keep collecting. Great.
Could you do like a subgroup analysis or
maybe? But I mean, it's a big difference.
Yeah.
So you look at Well, we'll see. Your registration, how does it?
Right. One thing to keep in mind in all of this is that we are focusing on the level of correlation between the structural and the functional, right? And this is where the field maps are helping. They are giving our like correlation to be much higher quality. And we care about those cases, the correlation, mostly when we do either surface-based analysis, because we extract the surface from the structural data, and we want the surface to be a good representation of the gray matter voxels in the functional data as well. Or when we do surface-based ROIs, like our speech lab ROIs that are surface-based. So if you don't do that and you just care about volume-based analysis, then these differences that are very visible and notable, they don't matter that much, because we don't care about that level of correlation between structural and functional unless we use the structural data for something to specify the individual voxels. Once you have the data in M&I space and it's supposed to be relatively in a spatial frame that is similar across subjects, and all you care is about the similarity of one particular voxel location across subjects. You don't care too much about the level of correlation between that voxel, gray matter voxel, and that functional data and the anatomical data for that same subject, because you don't care anymore about the anatomical data for that subject. So again, just to put this into in the general context, that all of these field map acquisitions is very helpful, but we see very noticeable difference because we are focusing on the places where we know that we are going to see very noticeable difference, which is in the level of correlation between the structural and the functional data. For other cases, that doesn't mean that if you don't have field maps, you should throw away your data, because there are many other sort of analysis that you can use on that. And having the field maps is not going to help that much on those analyses.
Phew.
Just a general context.
That's good.
But I'm very happy to see this good level of correlation, because I mean, one of the problems with our all surface-based pipeline in the past and the surface-based ROIs is that all of the like increased sensitivity, all of the nice properties that we expect to have from using the surface-based analysis were not clearly panning out in terms of actual higher power to detect signals of interest and things like that. And to a big extent, that was because all of these residual misregistration issues. So I think we now have we're going to make our surface-based pipeline and analysis much more competitive now, the way that we are processing the data, and if we have field maps, basically.
Do you have?
Do you want to take a peek? Oh, sorry, go ahead.
I was just going to ask, have you looked at the first level?
So I have
Yeah,
I have
this is-
questions about my files. If you want to dive back into it.
Right. Do you want to switch to first level stuff then? We can talk about, continue where we left yesterday, or talk about how to specify config files and all of that information.
That's fine with me. That's fine with me. I was going to say, do you want to take a quick peek at the SCQPDS images?
Yeah. Oh, yeah, definitely. That's a good idea.
And then we can look at yeah. Yeah, so I just used the template that was in the FL software folder, so that would be indirect.
We can check.
So yeah. With field maps, yeah.
Right. Perfect.
Oh, okay. All right. Hold your breath.
Did you want to look at any of the other trade plots first?
No, it's okay.
Right. When we are doing this type of like M&I pipeline, we typically also want to double check that the plots, the quality assurance plots that show you the M&I boundaries, basically to make sure that the normalization works correctly. Again, this is something that rarely fails, but it does fail from time to time. So one in every, I don't know, 20, 50 subjects will fail normalization for no good reason. So it's a good thing to check that as well.
Should we start there today?
Sure. You can go any of the normalization ones, right? The functional data. This is the indirect normalization, right? So either the functional or the structural are going to look. Both of them are going to be fine. Functional is a little bit more complete because that could fail because the normalization fell or because the co-registration fell. So if the co-registration between the functional and structural failed, even though the structural normalization might have worked, then when it applies that same transformation to the functional, it's going to look all funny. But, yeah. And that looks perfectly fine. Yeah. Yeah, you can go with the error keys as well, just to make it faster. Nice. Right, that looks fine to me. What do you say, Jason?
Yeah, I was marking that as you go through, you see the slices change. But the outlines are the same. Range shapes change a bunch, and yet you still can only think, oh, that looks good.
Well, this is there's a lot. There's like other stuff outside the M&I space that keeps moving around. So, yeah.
It's supposed to, though, right?
Yeah.
I mean, okay.
Oh, do we want to look at the structural underline or go straight to registration?
For today, we can skip.
Like obviously, yeah,
one
you
should
want,
look at it.
want
Yeah.
to go through all.
But Alfonso, is there a way to change the brightness of the functional data? You can
Yeah,
change
right
the
there.
color now.
Yes, that.
I guess really what I mean is, I guess, contrast, but this is fine.
Right. Perhaps I can make the brightness button to do something like a mix of brightness and contrast.
Oh,
You can also change the color map. So basically, if you go to the background, oh no, the color map of the background image you cannot change. Or can you? I don't recall. Background.
No, it's not a big deal.
Nah, perhaps you can't. That's the overlay color map. You can change the color map of the overlay, but not the background image.
So you-
Here you want
It's good.
So that goes all the way over.
yeah. So we should make it all. You want to like expand it first, right? So that you can actually see what.
Yeah.
That's good. Yeah.
So I would say, if you were to switch this to axial. It's probably a more efficient way to get a sense because you can see the front and back of the brain at the same time. Let's see. I'm gonna go through those. Yeah, it looks pretty good. Remember we talked about just like here, we talked about as I developing heuristic here, yeah, well, that is that. It's shifted data. And in here, up here, you're going to start to see the surroundings down. I think you're going to see that, well, the field maps don't always fix. Does it look like there's a pretty good match here and a pretty good match here at the posterior part of the brain? And that's you can see that we lose some detail.
Yeah, the gray white matter boundary, it looks like the posterior parts of the brain is like it's almost too far out. It's like it's the gray white boundary, or the approximate gray white boundary that we came up with is kind of going almost to the edge of where the signal is functional data.
That could be just working.
This does include like two of the subjects though that were missing some functional runs, and they had some motion. Oh, this is just one.
This is the first subject.
Oh, okay.
All right, that looks pretty good to me.
Yeah, that looks perfectly good to me as well.
Yeah, so it's like, do any
Yeah, random sampling works best.
It was S01 P11. Or was it tricky?
Well, there were two. PDS 02 P07 was one. I think the other one was P16. But these two subjects were missing multiple functional ones, and they were also like outliers with regard to their mean motion.
But this is just one volume, right?
So you can, yeah, so the motion, if a subject moving a lot, I can imagine, Alfonso, that you have trouble with the normalization co-registration, but really it's not independent.
Okay.
It shouldn't. I mean, the sample image that is used for the normalization and the co-registration is computed after the outlier detection. So anything that is showing a lot of motion is disregarded when computing this average image. So basically, the ART step computes its own average functional image that tries to actually disregard totally the functional time points that are outliers, so that it's a little bit more robust to this sort of like motion that would affect the quality of the functional data for co-registration and normalization purposes. And that will happen automatically as part of the pipeline as long as the ART step is before the co-registration and normalization, which is the case in our pipeline.
Is it so? This functional image an average across all functional images?
I think so. Could you go to effects and the last option in there, the info, just to double check what is it that we are showing? Yeah, it's called the art_mean_usub. So this is the one that is computed, it's the average functional data that is computed by art. And that's the average functional data across all time points, except those time points that have been identified as outliers.
This run 01?
Run 01. It's just because it inherits the name of the first image of your entire data, but it's actually the average across all of the time points for all of your runs, whatever number of runs that you have. Yeah.
Can we, Alfonso, the structurals at this point, they're not intensity normalized by any.
Right. I'm not sure. Could you again check the name? They would have an M on their file names if they are, but I think they are not. But yeah, no, they would be in. So they will be called like WC0MC sub. If they are intensity normalized, there is a one procedure as part of the normalization that does this intensity normalization, but I don't think that we output those files. Just not to have too many. Do you think it would make more sense to have those?
I was thinking that one of the, when you look at these, the contour, this yellow contour,
Right.
image intensity, there could be some drift.
Right, there can be a drift, like a spatial drift of the intensity values. Yeah, that's a bad thing for this type of contour plots. You're right. It would make more sense to look at those images after this, like drift corrected images. I'll take a look if I can easily generate those and put them in here.
That's good. Would you be able? Why don't we look at it? Is it P11, Matt? The one that's the one where we.
No, 16.
16. It has the registration.
Mm-hmm.
I think you can just stop. But, well, it's up to you, Alfonso. If you think you gain something by looking at the whole thing, but if you look here, it looks like we're doing. Well, I guess it looks like we're doing the first guess here was pretty darn good.
You can't actually see where the gray white, like where the gray.
Well, you can sort of see it, right? And the shadow that's inside the yellow is the structural data.
Right.
Oh, but is that shadow there? Is that always there though?
So if it was,
It depends on the choice of the threshold. Right?
yes, it would be.
No, but I mean, like if you go all the way in so that it's really tight inside the white matter,
It still shows the shadow. Well, yeah, that's a good point. That could be actually part of the smoothing. Could you go to effects and check something that is called, what is it called? It's called raw data display. It's almost at the bottom, instead of the smoother display, raw data display. So that avoids any some sort, there are some spatial interpolation things that are done just for producing better, like higher quality images, but that basically might be producing that. So change the threshold and see if that is happening. Yeah, that doesn't show that shadow now, right?
Is it possible to be able to set this basically
the default
structural there, and you set it, and then right so that it's not eroding away, or yeah. I mean, ultimately for this is all fine, but that fact that shadow's there, you can make a mistake. I think you just
right. That's a good point. Yes, I mean this smoothing for interpolation, it kind of like works better in most cases, but you're right, for this it might be misleading.
Okay, so it's gone. Someone can tell me how that.
In effect, there's an option for.
No, but I can easily change the defaults for this particular display. I can change the default for this like a functional anatomical co-registration plot to actually change that value just for this case. So it's simple to do that. Functional co-registration quality assurance plot. Just make the raw option the default. No problem.
Yeah, I saw a couple little spots here and there, but they're in the areas that we think are going to.
Yeah.
Okay. So I guess we're just we already looked at what this looked like a sample of these data sets that had without the field maps. My recollection is that this does quite a bit better. So I'm assuming that this is doing better. But yeah, you see like here, it's quite perfect. But that's what we're expecting.
I mean, we don't really care about the acceptable.
All right. So these look pretty good. I love that.
Yeah, looks perfectly good. I don't see any residual effect of motion as well.
They look pretty good.
Is there any other sort of flashlight cuts?
So first level. So this could potentially change your result a lot. Maybe.
There's been many times we thought results would change a lot because of things
Right.
we discovered.
Ultimately, it will change the most when we just stop getting rid of the stop removing that controlling for duration, which we weren't doing before yesterday. I think we were doing it 2 years ago.
If someone wants to open it's like speech and then first level speech and then first level speech no MT. Or else you can just be.
Yeah, I'm gonna do it. But if I would take a break for 1 second, too. Great.
So what is the advantage of using a continuous acquisition for repetition suppression as opposed to sparse sampling? Because like to me, would that just make it?
I don't know the original intent, because so the repetition suppression study, there were these blocks of speech. So there was like 6, like every trial was 6 different utterances. It was like there was a pair of like 2 that were the same phonemically but switched around. Then you would have like 1, 2, 1, 2, 1, 2, and so potentially if you wanted to model a subset of those, like if you just wanted to model the first 2 as saying, okay, that's the speech that we care about, then
I see what you're saying.
You don't need that to be in the right exact place because you're getting a constant acquisition.
Yeah, and you want to see like what areas are kind of habituating, right?
Yeah.
Over productions, right?
Exactly.
Okay, so that makes sense. But I guess it's sort of more prone then to these like motion artifacts and things, right? Because they're right.
Just have to worry about slice timing correction.
Right.
Yeah, and then you have also much fewer acquisitions typically as well.
Yeah. But you have fewer in the continuous or fewer in the...
In the sparse sampling, typically you have for the same time segment that you like say for the subject within the scanner, you typically can acquire much less data.
Right.
That makes sense.
Okay, so I opened the first level complete files as well as a session design file. So I might start with the session design file just to make sure that everything is as we expect. So I think the idea right now is until I guess we have a maybe better understanding of exactly what how to specify the covariate, etc. The whole discussion yesterday that for now what a run is not using the interaction term, just using the p-mod in one version and not using it in the second.
That sounds perfect. I have one question for you guys also regarding the interaction. I actually look at the code in MATLAB, in SPM, sorry, and what I was thinking yesterday was the case basically. So SPM is internally doing this orthogonalization of the basically interaction terms, so that they are orthogonal to the conditions, and it's doing that in a way that is separately for every condition. So if you do something like duration factor and you as a parametric modulator to 2 conditions, condition A and B, like a normal and fast speech, for example, it will be by default done in a way that it subtracts the average temporal. It basically centers the duration variable separately for the condition A, for each condition, for the fast condition and for the normal condition. That is, but that is not what we want to do typically when we want to actually correct for the potential difference in duration across the two conditions. So we need, I need to basically enter and give you guys an option as part of the configuration files to specify whether you want to center or not. So I was thinking of at least a few possibilities, and I don't know which one do you think it makes more sense. So the first question for you guys is, when you are entering PMOD and you say like the PMOD value, and you enter something like I have a parametric modulator that is duration, and you enter PMOD value 1100, saying that this parametric modulator applies to two conditions, what do you expect for that to mean? Do you expect it to mean that you are modulating, you are modeling the effect of your parametric modulation to be the same across those two conditions, or you are allowing it to be different across the two conditions that you are selecting? So do you expect, this is kind of similar to whether you are modeling something that is session specific or session invariant, right? When we have multiple runs, you can estimate, and you estimate a condition. Do you expect that condition effect to be estimated separately for every run, or to be estimated uniquely across all the runs? And that's kind of like what the model session does for you. It allows you to choose between those two options. So I wanted to check with you, when you are doing the same thing for a parametric modulator, do you expect that parametric modulation to be computed separately for every condition that you specify when it applies to multiple conditions, or do you think that the reasonable expectation when you set that is that parametric modulator is the same across all the conditions?
I think it would make intuitively, you would think that it would be one. It would all be on the same in the same regressor, but that might. But well, I guess as long as we know that it's doing that, then we can respond accordingly. Because if it was an issue of differences in speed and duration between the two conditions, and that parametric modulator was the same regressor for across both conditions, then potentially the effect of that regressor would remove the difference in effect between the two conditions, right?
Right, exactly. But so I mean, when you are creating this thing, for example, and you want it to apply to two conditions, you have two options. I mean, it's not very clear in the way that we created these config files which one of the two options do you want to use. So you could create two parametric modulators, just duration, one for one condition and another for another condition, and enter them like two PMOD lines. You say PMOD 1000, 0100, and you are basically creating two parametric modulators. The first one applies to the first condition, and the second applies to the second condition. Or you could just create one parametric modulator because the values are just the same, right? It's just duration, it means the same, and enter a PMOD value of 1100 and saying this parametric modulator applies to two conditions. So it's not, I don't think that in the way that we are creating these configuration files, it's very clear what the difference between those two cases would mean. I just wanted to grasp basically what do you think that you are getting when you are specifying one of these options? So to kind of, I could. It's just to help me basically how to best specify the option. I could make it give you an option very similar to the model session, that it could be something like PMOD condition or something like that, that allows you to set to 1 or 0 if you want these parametric modulators to be condition invariant, or do you want them to be condition specific?
I like having it as an option that we put in because it forces us to actually think about which we need.
Right.
Like sorry, I didn't quite hear it. Could you repeat it, please?
So I like it where it's an option that you're kind of forced to specify it, because it makes you think about which one you actually want versus just it defaulting to.
Right, exactly. That's a good point. To what extent this is so? Do you okay? Do you have any particular recommendations as to what type of configuration? How would you like that information to be specified that it makes sense to you guys?
I guess the most straightforward way is would be you just have a column of like one number for every day of the trial, and then either you also specify right there the condition, but that's also specified elsewhere. So that would be the easiest thing, rather than having two columns.
Right, and right now you can enter multiple columns as well. I mean, when you specify a PMOD parametric modulator, you can enter multiple ones. You don't have to specify just one. So instead of having in there just a single column, you could have them multiple columns, 2 or 3 columns. And then when you, in the line where it says PMOD names, you could have multiple names in there. You can say MT, and then duration, and then speech rate, or whatever other measures you have. And if you define like 3 names, then you expect to have like 3 columns in the PMOD values. And then when you specify the PMOD line, you can actually have multiple lines. And in that, if you have like 3 parametric modulators, you can actually enter 3 lines after the PMOD thing, specifying to which condition each of these parametric modulators apply. And the question is basically when you have one particular parametric modulator that applies to a single condition, sorry, to multiple conditions, I'm not sure whether whether it makes more sense to basically give you an option to assume that the default in that case is going to be that the effect is going to be the same across all of the conditions that this parametric modulator specifies, and gives you the option to change that default, or as Lane was saying, basically give it like a different name. I could give something like a parametric modulators that are condition invariant or something like that to specify the ones that you want to be common across multiple conditions, and have another way to specify parametric modulators that are condition specific, and they are like, even though they apply to multiple conditions, they basically apply separately for every individual condition because they are going to be estimated separately for every condition.
You could do something like, you know, put in like a PMOD, I don't know, invariant or something, and then have it, you know, set to 1.
Or I guess
And then
just
zeros,
or just do 1.
or because it would be the same before.
Right. If you only have 1 PMOD. Yeah. And if
And
you
then
have
0 if it's specific to.
Yeah.
That's right, that's a good point. You could specify a PMOD invariant field that has like 3 values if you have 3 parametric modulators, and just say 1 or 0 for each one of those 3 to specify whether you want them to be invariant. Okay, so that's going to be similar to the kind of like model session type of thing, right? So
Yeah.
basically you are saying whether you want that parametric modulator to be invariant across all conditions or not. Okay, that's helpful. Thank you very much.
I like that.
And so then, like, or if you had like, you know, very 2, then this would be, you know, here.
Right, exactly. Like 2 values, and specify which one of those is actually invariant and which one is a condition specific. Okay.
Question.
And the default, what do you think it makes sense to be? If you don't enter the PMOD invariant field, what do you think it will make more sense to leave the default assumption to be? Or do you want me to force you to actually specify the PMOD invariant field, so that I force you to think about whether you want them to be invariant or not?
We're supposed to think about
the default pipelines can have it set as 1 or as invariant. So we're controlling for the modulator as a first-year student.
Okay, so I'll force, I will error out, the code will give you an error if you don't enter the PMOD invariant field for a PMOD for a parametric modulator. Is that okay?
And in the sample config file.
And then the sample config file, so make sure to enter that line so that it's not all confusing. Perfect.
Thank you.
And then maybe for our next lab meeting where we're discussing this, we can have a clear idea of what you get to.
Right, when to have it as invariant and when not to have it as invariant, and in which cases it will make sense to do one or the other, right?
There are some things we can explore
Right.
when he might actually give us some pretty useful information.
Now, so currently as it is right now, is the PMOD, when you enter a number in for each of the conditions, is that if you have 2 different parametric modulators, it would just be, you would have 2 for that condition? Or
Sorry, do you mean here or?
no, just the PMOD, hash PMOD. Nope, one above, yep, right, where there's 1110, 1111.
Yeah. So you would have an extra row, right?
Right, and
Oh, okay.
typically just enter that as 2 additional rows below pmod, just to not make it confusing. But it will read it anyway, whatever way. So all of these fields, sometimes you can put the values at the right of the field name, or you can put the values below them. Typically, when there is a single line, I write them just after the field name. But if there are multiple lines, it looks cleaner if you just add them as multiple lines below the field name. But yeah, if you have like 2 parametric modulators, you will have 2 rows of pmod values, one for the first modulator and another one for the second.
Your values here, they're demean,
Yes,
and does that have an effect? Is that,
excluding the baseline.
so, and they're demean for the mean that's across both, like all of speech.
Oh,
Is that something that we need to consider when we're doing invariant versus non-invariant, Alfonso?
I didn't understand the first portion of the question. Sorry, could you add?
So these p-mod values are d-mean, and so the mean duration over the whole run, right?
Right.
All speech trial, the whole run, right, is removed. If you wanted to do it the other way, not the condition specific way, would you then have to be careful about how that mean was removed?
Right. So when the effect, the pmods are not invariant, then the SPM is actually doing this centering for you, and it's doing it separately for every individual condition. So it's taking these pmod values and it's removing the average for every individual condition separately before entering them as the multiplication factor into your design matrix.
Right.
So in that case, it doesn't matter how you center the values or not, because SPM is going to actually center them for you. Only when you have the pmod invariant option that we don't have it yet, and set to 1, basically that will skip the SPM orthogonalization step. So SPM won't do this centering of the values, and then it will matter how do you center them specifically. And typically you will want to center them across like a single entire run rather than separately for every condition, but there might be cases where you might want to do otherwise. But in general, I would say that you want to center them across entire run rather than.
Does this then mean that you can't just list the pmod values? You put them in this config file, and what would be nice is you just put them in and then you just pick invariant 1 or 0. It sounds like you need to. So
it's not like if you push it this way, you can do either.
You can. Is that true? So you're just getting rid of some constant value, and then it'll actually also still get rid of. It'll actually get rid of whatever non-zero, the mean within the condition. Is that the same?
Is that how it's working, Alfonso?
I'm not hearing Jason. Sorry, I'm hearing the guys at the other side of the table just fine, but either Jason needs to like scream louder, or you need to move the microphone. Sorry about that.
So is it automatically when you put these in for one column, if you have pmod invariant, then will SPM demean those values in one regressor when it enters into the design matrix?
It won't, but I need to change the code so that it doesn't. Basically, the code doesn't have the pmod invariant field yet. I'll add it, and I'll make it so that when you specify pmod invariant to 1, SPM will skip that centering, basically, because otherwise SPM does include the centering by default. It's orthogonalization of all of the condition-specific effects. So basically, anything that is a condition parametric modulator gets orthogonalized with respect of the things that appear in the left in the design matrix. And because at the left of the design matrix, you have the factor that it hasn't been multiplied by the duration values, basically that means that it's effectively the same as demeaning the pmod values, the duration values that you're entering separately for every individual condition. So that's what SPM is doing right now, and it's what SPM will continue to do as in the next version of the FL scripts when you do the pmod invariant set to 0. When you have the pmod invariant set to 1, then I will have the code skip that normalization, so it doesn't do any sort of centering. It will respect the values that you are actually entering as the pmod values without any additional transformation.
And would it matter if we wanted to actually estimate the effect of that modulator, though? Because don't you usually recommend
Oh, that doesn't matter at all. No, when you are estimating the effect of the modulator, instead it doesn't matter the actual centering value. That doesn't affect that. That's affect only the other stuff. So it's kind of like the same as with a regression, right? If you have a regression, you have the constant term, and then you have the regression values, and the question of whether you need to center or not the regression values that you are entering, it only affects at the estimation of the actual intersect, whether you center them or not, because the intersect is going to change whether the regression values are centered or not, because you're basically moving the whole plot towards the right or towards the left. So the intercept changes, but the slope doesn't change by this centering process, because the centering just only moves the data points to the left or to the right, so it doesn't change the slope of the lines. So in this case, it's also the same. If you are interested in the effect of the parametric modulation itself, you want to compare the slopes of the interaction effects of the duration across two conditions or something like that, and whether the duration effect is different between the two conditions. It doesn't matter whether you have centered these things or not. That centering only makes a difference when you are comparing the other effects, the actual condition individual effects after controlling for the effect of the parametric modulator. Make sense?
Yeah. Oh wait, can you say one more time when you do need to center?
So I think I'll be a little bit more clear when I send you a few examples of. I create some document where I have a few examples of when you would need to do one way or the other. But in general, you need to center things. Well, whether you center them or not affects basically the cases of when you want to control for something, because when you have a covariate that you want to control for it, then you need to think a little bit about whether you need to center it or not, because those are the cases where it makes a difference. When you want to use a covariate as something that you care about and you want to estimate the effect of that covariate and see whether it's different across two conditions or something like that, in those cases you typically don't care about centering at all, because the centering of that covariate doesn't affect the slopes, basically the effect of that covariate, that is going to get the same value.
But then as a default, we could center.
So the default right now is for everything to be centered. I mean, it's the way SPM does it. SPM, when you enter parametric modulators, the default is to have everything centered. So it removes the average for every individual condition. Sorry?
But we wouldn't need to center it ourselves, right?
No, yeah, right. It will all be subsumed as part of the PMOD invariant field.
Right.
Basically.
So,
But then if it's already centered, is that okay?
It's perfectly fine. I mean, as long as you don't, I mean, if you go and center them separately for every condition, so you take these duration values and you remove the average within each condition separately, and then you enter those values in there, then the PMOD invariant thing is not going to affect anything at all, the PMOD field. But that is a very cumbersome case, right? The scenario. You typically don't do that. You just enter the actual raw duration values, and you might enter the raw duration values centered across the entire session, but never. Or it would be very strange that you would actually enter those duration values centered across within each condition separately, right?
But is PMOD invariant where you add a regressor that is irrespective of conditions, that there's just one regressor, right?
Sorry, I didn't understand the question.
All right, yeah. If you were in the future FL script pipeline, if you have PMOD invariant set to 1, then in the design matrix, there would only be one.
Yep, exactly. So in your case, remember that you were seeing like 2 columns, one for the duration for condition A and one for duration condition B. If you set PMOD invariant, you're going to see only one column in your design matrix that contains the effect of duration that is kind of like the same constant across the two conditions, and that's why we call it invariant. Okay. Basically, it's just the same effect across all of the conditions that it might affect. Okay. Make sense?
Right.
Yeah.
I definitely need to double check how I centered that data. I don't know if it was by session or by session.
Yeah, ideally what you do is you just in these config files, you just enter the values and then you let, right? Right, is that, I guess.
Right, I think that the general recommendation would be that just enter the actual raw values and then care about whether we need to center them or not in terms of basically other stuff, but don't manually center it. Just center the actual raw values. Yeah, because even in the case of I could give you an option not to, but I don't think there is a reasonable case where you might not want that to happen. Well, no, there might be. Yes, okay. So I might need to create like another option, but this would be a little bit more like a corner scenario type of thing, where you might want to specify manually whether you want SPM to center your data or not. And that will give you some flexibility to do some kind of like very weird corner cases. But I'll just try to write that example into when I write the documentation for what to use with this PMOD invariant thing or not, so that it might be a little bit clearer. But I think with the PMOD invariant, we cover pretty much all of the use cases, or most of the use cases that we will have for this type of parametric modelators.
I just want to do a quick sanity check about how I deep this data. Oh, never mind. I can look for it later.
Yeah, so you're removing the mean of the empty row stream in the speech IDX. Speech IDX is the entire speech stimuli, so everything minus baseline, or what is it?
Mm-hmm. Yeah, I think I subtracted all.
Oh, where the values are different than zero. So you're subtracting the average across all of the non-zero samples. Just fine. Yeah.
Okay. So then we're probably ready to look at the first level config file. So this is what I understood from yesterday, that if I wanted to, so if I use this in combination with that session design file, then that would still include like the covariance.
So you're saying like if you add in the PMOD values, but you don't have that interaction term here,
right,
it still includes it in the
right
design matrix.
Compared to this, where I have specified a PMOD.
Right, I see. Yes, exactly.
So that basically then says to ignore the covariance.
Yeah, so the design information basically for when estimating all of the parameters for this particular subject and for this particular number of runs, basically they will have the information about all of those parametric modulators in the other case, but not in this one. So you will see extra columns in the design matrix for the other case that are not present in this case, basically.
Mm-hmm. So then I just need to, well, I think, so once Alfonso updates the code with the session invariant thing, then I can just run these two.
Yes, it sounds like that if you just remove that session invariant thing right now and ran it,
What we think.
Right?
Okay, so then.
Well,
What is that doing right now?
What it's doing right now without the interaction term
Mm-hmm.
and the contrast, right? That's effectively acting as session invariant, Alfonso.
Sorry, again, I didn't quite hear you.
Well, assuming that you can't later tonight put the session invariant variable into the pipeline and get it working how you want. Could Elaine go ahead and run this without that? But let me rephrase the question. If she were to run it now with the session invariant variable removed, would it be actually acting as though she was running session invariant?
Right, if you run it now, basically as it is with the code as it is, it will be exactly the same as what it will be in the future if you run it with the PMOD invariant set to 0.
Set to 0.
Right, because that's what it's doing now, right? Is every parametric modulator is specific for every condition. If you enter a parametric modulator like duration that applies to multiple conditions, it's going to estimate the effect separately for every individual condition when it appears. So that's when it's not invariant, right? So that's what is happening right now, and this is what SPM does by default. And I'm going to just add the option to set that to 1, the invariant, when you don't want that to happen. And I think that I won't have any default. If you don't enter a PMOD invariant, it will error out and ask you to enter that information.
Okay, so we'll hold off.
So then the last thing. Oh, you going to
No,
say
that's fine. I was going to say that there is a complex way. If you really cannot wait, there is a complex way to actually run it in the same way as basically what it will be with the P-mod invariant set to one. But it's just way too complex to actually.
I think we can wait.
Are you really desperate to see the results or not?
Early Christmas. Actual.
It's going to spoil your Christmas if you don't see like
Stress and starting with significant difference. But I guess we'll wait. For the new year. New year. Yeah.
Yeah, okay. After the
2019 is the year for S right.
Yeah.
8 years of charm.
Oh yeah, so then I had one final question about this config file. So in the past we've talked about the effective smoothing level, and I think we want, right now I think it's set to minimally smooth, but I think we possibly want max smooth because we're comparing speech condition, speech condition. Or is that an open question?
Well, so doesn't that sort of depend on the pipeline, right? Doesn't that depend on what? So if we're doing this, if you're doing surface-based analysis, wouldn't we would want minimal smoothing at most, right, Alfonso? Or well, no. So,
well, not necessarily. I mean, so in the surface base, the smoothing happens at the level of the surface. So that kind of like a lot of the functionality of the smoothing is basically to increase the signal to noise ratio, to make the results a little bit more consistent across subjects, spatial location, or make the results at least the second level analysis a little bit more robust to variation in the location of the activation across subjects. So I think in general you want to have the smoothing level set to 2, basically the larger smoothing, unless you are looking at something that you know is a huge effect, like a speech minus baseline, and you do care a lot about the spatial localization. You don't want to smooth the boundaries because you really want to ask a question that is where exactly the activation is happening, and you are asking that question for, I don't know, you care about some very small region, and you want to see whether the activation is within that region and not want to blur the result by the activation of nearby voxels. I don't know. What do you think, Jason?
that sounds reasonable. I guess what I was wondering is, are we doing some smoothing in the surface-based pipeline?
Right. We are not.
First level.
No, we are not. We are not doing any surface at the volume level. And remember that we had the option before to have two sorts of smoothing in the surface-based pipeline. We could smooth the data at the volume level and then smooth it again at the surface level. And the volume level smoothing was to basically correct for these things that we are trying to correct for now with unwarping, basically, because we weren't basically extracting the activation from the right locations before, and we wanted one way to improve that basically was to smooth the data in the volume at the volume level before actually extracting the time series at the surface level. But I don't think we might need that option any longer. What do you think, Jason?
That would be great. It does look pretty good. The co-registration.
Right.
So that would be great.
To my eye, the correlation is good enough so that we really don't need to one-on-one to smooth the data anymore at the level of the volume, because I mean we are having a very good respect for the boundaries, gray matter boundaries in the functional to structural correlation. So I don't know if we find that it's still not as good, and perhaps I will add it back, the option to smooth the data, or we could have it. I mean, you could just add it as an additional step there. I mean, it's very simple to just modify the pipeline, the surface-based pipeline, to add a spatial volume level smoothing before doing the extraction of the functional data. So something that we could play with, right?
So a study that didn't have field maps, for instance, one might want to entertain
right.
Small
right.
volume smoothing.
Right. That's
or just doing surface-based analysis.
If you really want to do surface and you are finding that the correlation is not that great, then you might want to try adding smoothing prior to functional data extraction to see if that helps.
Is there a way to add that in at the level of the volume?
Sorry?
So I think, so what, my understanding of what you just said was that if you didn't have a field map, you're just saying to do the volume analysis. Don't do for it.
Well, no, what I was saying is if you want to do surface level analysis and you find that the correlation is bad because you don't have field map, and you still want to do surface-based analysis, you could potentially add a smoothing of the functional data before doing the extraction of the time series at the boundary level. So that is a little bit more robust to those miscorrelation between the functional and anatomical data, right?
So would we add that into the pre-processing pipeline?
Right, and that would entail just adding the functional smooth. So it would be a single line. It would be called functional smooth as one. When you are listing the processing steps in the processing pipeline configuration file, you could just add functional smooth right at the after realignment and ART outlier detection and before the extraction, the correlation with the structural and everything else that happens in the surface-based pipeline. So that the smoothing actually happens at the level of the volume before the extraction of the data. Let me look at the names of the things so I can tell you where exactly to put it. So functional evaluation space. This is not the pipeline. Preprocessing. So surface. Okay, so in the surface-based pipeline, we have something that it says VDM create, then realign and warp, then ART, then corregister to fine correlation to the structural. Then it says functional surface resample. That's where the actual data is extracted. The functional data for every voxel within the gray matter is extracted, and then after that point, everything is done at the surface level. So as long as you do the smoothing before that point, so basically I would put it right after the functional ART step, that would basically be done at the volume level and will happen before the resampling. So that will make the resampling a little bit more robust to miscorrelation issues. I don't think that is a thing that we will need to have it by default in cases where you do have a good correlation, but it might be a way to improve the sensitivity of the analysis in cases where we don't have a good correlation and we still want to apply surface, well, we want to run surface level analysis or use surface-based ROIs.
Okay, great.
This was very
Alfonso, I had just another question that for you about the DB search database. And maybe, so how do I find out for all of the subjects that were run through that pipeline, what the ART thresholds were? Because I'm writing up that paper now and realize I don't know where that is.
Right. I mean, those were run in a relatively old version. I mean,
is there somewhere in like a .mat file that has that recorded?
Right. Yes. It depends on the version that they were run. So the current version of the pipeline basically creates log files, so you have text files that contain all of that information. Right. A little bit older than that, the version that we didn't use that. The version that we use for the DB search for the data that you're thinking about that hasn't been run in any version that keeps these SMAT files that contain those parameters. You can guess it. I mean, just take a subject, look at the actual outlier that has been identified, and look at the time series. You have some files that are called, I think they are called art underscore. Let me quickly check. There are some files that are called art regression. No, art time series. No.
You guys.
Yeah, art regression time series, and then the name of the functional data, and that will contain the two time series, the subject motion and the ball signal change. And those are the time series that get thresholded. So any value in those two things that are above the threshold values are the things that are marked as